Hello and welcome to this Synoptic enthanedioic acid question. It's from question number 3 from the 2018 OCR Unified Chemistry paper. The first part is about drawing optical isomers of a 6-coordinate complex with 3 bidentate ligands. So as you can see, you have the enthanedioic ligand with 2 negative charges, meaning 2 separate places where lone pairs that can involve themselves in coordinate bonding are found, hence the bidentate ligand. It tells you that it reacts with Fe3+ to form a complex ion with 3 enthanedioic ligands. It has 2 optical isomers. They want the 3D shapes of these optical isomers with the structure of the enthanedioic ligands and any overall charge. So looking at the structures from the mark scheme, let's have a look at the key features they have. Firstly, wedges and dotted lines. The wedges are there, dotted lines at the back there. Then the octahedral shape with a coordination number of 6. So 1, 2, 3, 4, 5, 6 bonds. All coordinate bonds are to the negatively charged oxygen atoms. So therefore, those oxygen atoms are the ones that need to face inwards towards the Fe. And then the charge on the complex is correctly calculated as 3- because you have 3 negative 2 bidentate ligands and 1 Fe3+, so overall 3- outside the square brackets. The isomers must be mirror images of each other, so in other words, in this case, the inward pointing enthanedioic ligand has to be matched on both sides, and then the outward pointing pair of enthanedioic ligands has to be matched on both sides. The next part is about a redox titration involving the enthanedioic ion and a previously unseen reagent, cerium 4+. So quite a lot of information here, so let's think about how to process it. First of all, it tells us that there's a color change next to the equation. So what this means is as the Ce4+ is added, it will immediately go colorless as it's converted to Ce3+. Further down, they've got 2 pieces of data. One represents the volume that the original rhubarb leaves dissolved in dilute sulfuric acid have been made up to. And then the second one is the sample from that was used in the titration. So this means there'll be a scaling factor somewhere, which is worth watching out for. So the first part of the question, it doesn't involve the titration results, it involves a color change. So taking what we've just looked at a moment ago and thinking about the end point, this is the point at which the yellow Ce4+ ions no longer have any enthanedioic acid with which to react. So taking the yellow color of the Ce4+ and reading the equation left to right, it would be easy to fall into the trap of thinking you're going from yellow to colorless. But what in fact is happening is all of a sudden the yellow Ce4+ ions don't have any enthanedioic to react with, so they're no longer turning to the colorless Ce3+. So the actual color changes colorless to yellow. The next part is about the titration itself. So it tells you that the trial titer has been omitted, which means that all 3 titers can be considered when making decisions about the concordant pair. So working out the individual titers, it's clear to see that the 2 that are within 0.1 centimeters cubed of each other are the first one and the third one. So therefore they can be used to work out the average titer. The next section involves turning back to the previous part of the question, which I've put in yellow, and I'm going to use the data moles equation moles answer technique because that allows us to process individual pieces of data one at a time, instead of trying to do it all at once. So the data for Ce4+ allows us to work out its volume and its concentration and therefore its moles. So therefore N equals V times C gives us 1.16 times 10 to the minus 3. In the equation there's a 2-to-1 mole ratio, so having the moles of enthanedioic acid gives us the moles of having the moles of Ce4+, I beg your pardon, gives us the moles of enthanedioic acid, which is 5.8 times 10 to the minus 4. So in a 250 centimeter cube sample, that would have been 5.8 times 10 to the minus 3. That was the scaling factor we were talking about. So I'm going to take my working up here now. And what I need to do is take the moles of the enthanedioic acid in 250 centimeters cubed and multiply them by the molar mass, which is 90 grams per mole. That gives me 0.522 grams. That would have been the mass of enthanedioic acid from the sample of rhubarb leaves. So dividing that by the original total mass of the rhubarb leaves, that gives me the percentage. Now the percentage is not in the form we need because we need to be an appropriate number of significant figures. The dot 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 means it's quite a long untruncated number. So therefore, looking at each individual piece of data, you can see that you've got the first three in our previous part of the question are 4 sig figs, and then you've got 5 sig figs, and up at the top where I've got my titration results, all of the highlighted numbers there are 4 sig figs again. Now clearing a bit of space and circling the two that I didn't highlight, they're 3 sig figs, so that's the least sensitive, which should be applied here. Therefore it's 0.631. So let's have a look at the mark scheme for the drawing the complex section. So first of all, there's quite a degree of flexibility here. But it's really important not to fall into the trap of using the curved line notation like you can see there, that you'll sometimes see incorrectly online. So this doesn't represent how many carbon atoms are present in the enthanedioic ion. So therefore you can see the way that they've drawn it in skeletal form with clear sort of changes in direction of our solid line. Now we'll have a look at the mark scheme for the calculation section. So you'll notice that this mark scheme doesn't permit the usual all 6 marks for 0.631% that you might normally see in quite a few multi-step calculation mark schemes. That's because they want to see your working. Now it's impossible to predict when or where they might do that, so make sure you include your workings always when you have a multi-step calculation like this. So common mistake, not necessarily because people don't know what they're doing, but more because they're under a lot of pressure in an exam and it's easy to forget to do this, is to actually use all 3 titles, so watch out for this one. So credit is only given for values worked out to 3 sig figs because they told you that you have to use an appropriate number of significant figures and they want you to work out that it's 3 sig figs. Okay, as always, thanks for listening. Until next time, see you soon.